Hi all, today we discuss section 22.9 central difference interpolation formula. In this section, the first central difference interpolation formula is Gauss forward interpolation formula. So that is given by y of p is equal to y naught plus p times delta y naught plus p times p minus 1 divided by 2 factorial delta square y minus 1 p plus 1 p into p minus 1 divided by 3 factorial times delta q y minus 1 plus etc. So this is the way we evaluate or interpolate the value of y at x. So here this p is x minus x naught divided by h, where this x is the value to be interpolate. Now we have how to identify this formula for the beyond this fifth degree term. So for this we need to follow a rule, or you need to remember this fact. I write this is y naught and this is our delta y naught, and we write all the differences, all differences of y minus 1 with all orders. So this will be square, and this is delta square y minus 2 delta raised to this is raised to 4 5 minus 1, this is delta raised to 4 y minus 2. I'll write it as delta raised to 4 y minus 2 delta raised to 6 y minus 3. Write all the even powers here. Delta raised to 8 minus y minus 4 here, and etc. So this is what we call the center line, and this is the way we remember this formula. That's the thing. This is delta y naught. Here we write again delta y minus 1, delta y minus 2, delta y minus 3, etc. with the power 1, 3 and 5. Here we have delta y, this is y minus 1, 2, 3 and 1 is already here. The first power term is already there. So this is our 5, and this is 7, this is 7, and this is 9, etc. So we have written y minus 1, delta y minus 1, delta y minus 2, delta y minus 3, delta y minus 4, etc. in the center line, what we call, this is our center line. Now this is center line, we call this as our center line, and this is the line below the center line. Okay, so we write this formula using y naught. This is y naught, the first term is here, and for the second time we write p times delta y naught. So we move on to this way, p times delta y naught. Then again we move on to this way. So from this on the second term we have delta square of y minus 1 with p into p minus 1 by 2 factorial. Okay, so we add one more term in the numerator compared to the first term, so that is p minus 1. Since there are two terms, then we have 2 factorial here. Again we come to the below line, that is delta cube y minus 1, that is in the third term with p into p minus 1. We add one more term, p plus 1 in the left with 3 factorial, okay, in the denominator. Now we move on to this way. Okay, that is the fourth term. Then we move on, then we add one more term, p minus 2 in the numerator, then divided by 4 factorial, since there are 4 terms in the numerator, and we take this term. Now we come to below line, that is delta raised to 5 of y minus 2, so that is this term. Then at that time we add one more term to this, p plus 2 in the left side, that is p plus 2, p minus 1, p minus 1, p minus 1, p minus 2 divided by factorial 5 times delta raised to 5. Then the next term we can write the next term as this one, that is we need to add one more term to the right, from this we add one more term the left and we write one more term, so that will be p plus 2, p plus 1, p minus 1, p minus 2, and p minus 3. This is the one more term. So since there are 6 terms, we have 6 factorial. Here we will write this delta raised to 6 y minus 3. Okay, then plus the next term contains delta raised to 7y minus 3. So that with this p plus 3 term, p plus 3, p plus 2, etc. Okay, so this is the way we write this formula. So this is what we call Gauss interpolation formula. Next we will explain one example to illustrate this formula. This is the example. Using Gauss forward interpolation formula, find the value of log 337.5 from the table. So this is the table. These are the x values: 310, 320, 330, 340, 350, 360. Then y values are this. So we need to find out the value of this y at x equal to 337.5. so this is our x, and that comes in between 330 and 340, so somewhere here. So this is our x value, 337.5. So how do you evaluate the y value at this point? Okay, so in order to evaluate this, or not to use the Gauss forward interpolation formula, we put x naught is the value given in this table just before this 337.5. so that is going to be 330. So this we set x naught is equal to 330. Now you defined p. P is our x minus 330 divided by 10. 10 is the interval of differencing. This is 310, 320, 330, 340, 350, 360. So the interval of differencing is equal, then that is 10. So p is to be defined as x minus 330 divided by 10. Okay, since our h is equal to 10. Okay, now we construct the table, the forward difference table. From that we can collect the values y minus 1, delta square y minus 1, delta q y minus 1, etc. So first we construct those Newton forward difference table first. Okay, this is our table. These are the x values. Then we evaluate p values for these x values. If x equal to 310, then first of all we write if x equal to 330, then the p value is 0, because 330 minus 330 divided by 10, that will be 0. And if x is 340, then p value is 1, and 350 p value is 2, 360 p value is 3, and for 320 the p value is minus 1, because this is 320 minus 330 divided by 10, so that is minus 1. Similarly this is minus 2. Okay, now these are the delta. This is yp's. Yp's are the values given in the table. So that is 2.4914, this is 2.5051, 2.5185, 2.5315, 2.5441, 2.5563. Okay, so these are the y values. Now the delta yp. So delta yp is the difference, the forward difference, this minus this. So 2.5051 minus this is equal to 0. Here we have 0.10137. Now we have this value is 2, so question we have 2 here, so we have 2, then this is 8, then the next value, the delta yp, that is this minus this number, so that will be again 0.0133. Here we have 0.0130, this is 0.0126, and this difference is 0.0122. Okay, so these are the delta yp's. Now we have that means delta y minus 2 is this one, delta y minus 1 is this one, delta y naught is this one, delta y1 is this, delta y2 is this. Okay, so this is the delta yp. The delta square yp will be this minus this one. Okay, so that is the difference between these two. So we have negative 0.0005, and the difference between this is negative 0.0003, and difference between these two will be negative 0.0004. This is again negative 0.0004. Okay, so these are the second order differencing, and third order differencing will be the difference between these two, that will be 0.0002, and this between this is minus 0.0001, and difference between these two, that is 0, so 0.000, because both the values are the same. And we have fourth order difference between this minus this, so this minus of minus this one, that will be 0.0003 minus, so this is this minus this, sorry, this is 0.002. The difference of this value is this minus this one. Okay, so this is obtained by minus 0.0001 minus 0.002, not this from this, because this negative number minus this number. Okay, that will be minus 0.003, and this minus this. Okay, so that will be plus 0.0001. Okay, so 0 minus of this quantity. Now we have difference between this minus this, so that is again plus, that is 0.0004. so these are the differentiation table or forward difference table to evaluate this formula. Now we evaluate this one. Okay, so in order to evaluate this formula, we need to get y naught first. Okay, y naught is the image of x naught. Okay, we have set this x naught is 330, so this is our y naught. Y naught is the value, this 2.585. so I set this is this is our y naught. Okay, to the form to this formula we set y naught as this, because this is our x naught. We take this is our x naught, so, and y naught is this one. Okay, now we need to get the second term. We need to get delta square y minus 1. Okay, so delta square y minus 1 is minus this is our y minus 1, this is y minus 1. So delta y minus 1 is this one. Okay, and that is delta y minus 1 can be obtained from this minus this. Okay, so that is this one. This is delta y minus 1. So delta of delta y minus 1 is delta square y minus 1. So this is our delta y minus 1, and this is delta of this, that is this minus this, so that will give delta square y minus 1, that is this number. Similarly, so our required values are, we need to take this value. Okay, and next we will take the value. So this one, the second time we have delta y naught. So delta y naught is this value, this delta y naught. This is the in the second term. Okay, so we come to this way, and we will take this one, delta square y minus 1, that is in the third term. In the fourth term we have delta raised to 4 y minus 2. Okay, so we need to take y minus 2. So this is our y minus 2, this is x minus 2, this is x minus 1. So this is our y minus 2. Okay, and this is our delta y minus 2, and this is our delta square y minus 2, and this is our delta cube y minus 2. Now we have this value, this is our delta raised to 4 y minus 2. So we need to take this value as well. Okay, so before that we have delta cube y minus 1. So we before that we need to take this delta cube. We have this is for the first term. I'll write it here. So this is for the first term and this is for the second term, that is delta y naught. For the third term we will collect this, that is delta square y minus 1 and delta cube y minus 1. So that is, this is delta cube y minus 1. We need to collect this also. So this is for the fourth term, so that is delta cube y minus 1. And for the fifth term, this is our fifth term, starting from this 1 2 3 4 5, fifth term, that is fourth order term. Fourth order term we need to collect delta raised to 4 y minus 2, that is this one. And for the last term we will collect delta raised to 5 y minus 2, that is this one. Delta raised to 5 y minus 2, that is this one. Okay, so first we take y naught for the first term. Second term we have delta y naught. Third term we have delta square y minus 1 and the fourth term we have this. For the fifth term we will take this term, and sixth, the last term, the sixth term we will collect this. Okay, using these values we will evaluate the y of yp, that is yp, that is going to be f of, that is log 337.5. So for this we have said this x naught is this one, and if x equal to 337.5, in this case what is p? In that case p is 337.5 divided minus 330 divided by 10, then that will be 0.75. This is 0.75. Now y naught, what is y naught? Y naught is our 2.5185. so this is we have the formula. This is the formula. We write a formula y naught plus p times delta y naught. So first term is y naught is, we will write the formula again, y naught plus p times delta y naught plus p minus 1 divided by 2 factorial delta square y minus 1 plus p plus 1 p minus 1 by 3 factorial delta cube y minus 1 plus p plus 1 p minus 1 into p minus 2 divided by 4 factorial into delta raised to 4 y minus 2. The last time we have p plus 2, p plus 1, p minus 1, p minus 2 divided by 5 factorial delta raised to 5 y minus 2 plus x. Here we have only this much step, so this is the value of this. Okay, now we substitute for this y naught. What is y naught? Y naught is 2.5185 plus, what is p? P is 0.75, and what is the value of this? Delta y naught. Okay, so we have written what is delta y naught here. Delta y naught is 0.0130. 0.0130. Okay, so that is the second term. For the third term we have 0.75, that is p, then p minus 1. Okay, that is this number minus 1. So 0.75 minus 1 divided by 2 factorial delta square y minus 1, that is this one. Delta square y minus 1 is this one, 0 minus 0.0003, and now we have the fourth term. Fourth term is this one, that is plus p plus 1, that is 0.75 plus 1, then 0.75, then 0.75 minus 1 divided by 3 factorial delta q y minus 1. Okay, so that is this one. Delta q y minus 1 is this one, that is minus 0.001. okay, plus the fourth term will be this number into, that is 0.75 plus 1, 0.75 0.75 minus 1, 0.75 minus 2 divided by 4 factorial into this number, okay, delta raised to 4 y minus 2, so that is minus 0.0003. Okay, finally we have the sixth term, that's start from p plus 2 into, okay, so what is p? 0.75 plus 2, 0.75 plus 1, then 0.75, then 0.75 minus 1, 0.75 minus 2 divided by 5 factorial into delta raised to 5 y minus 2, that is this one, delta raised to 5 y minus 2 is 0.0004. okay, now you simplify this expression and you will get this as 2.5282. okay, so this is the value of this. Then we can set log 337.5 equal to 2.5283. so this is the way we use Gauss forward interpolation formula. Thank you. The next class we will discuss another central difference interpolation called Gauss backward interpolation formula. Thank you.